Okay, the next section is 8.2 on the law of cosines. Okay, so we're going to use the law of cosines to solve oblique triangles in the case of side, 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 or side, angle, side. If we don't have these, we're going to have to use like the law of sines first to get more information. But we can do that as well, as you'll see in the homework. We'll do this to solve real-world problems, and we'll use Heron's formula. I don't have any of this in the web work, but this might be on the quizzes, so we will practice this at some point. Okay, here are the formulas for law of cosines right here. There's different ways to write it. So let me draw a picture of a triangle real quick. Let's say this is A, this would be small a, this is, if this were C, this would be small c, this would be small b. So there's different ways to write this. You'll notice that the key is that if you're looking for side A and you put that there, the angle across from it is angle A, and that goes here. So that's the key to this. If you're using B, angle B goes across from that, and the other two leftover pieces go here and here then, with each of the cases. So you'll notice that pattern, and you can use the formula appropriately. If you do solve this for cosine of A and you're looking for the angle, what you do is you subtract B squared and you subtract C squared, and then you divide by this quantity, and that's why you get this right here. So if you go to solve this algebraically for the cosine of A, you will get this quantity right here, and that can be a little bit tricky with the algebra. That's probably the hardest part about this section. The rest of it's pretty straightforward. So here's an example then where we're given all three sides, and it wants us to find all three angles. So I'll use any one of these formulas, it doesn't matter. I'll use this one, a squared equals b squared plus c squared minus 2bc cosine of angle A, and I'll solve for A right there. So I'm going to subtract b squared. I'll do this before I even plug it in, just to show you the algebra. So I'll subtract b squared, and I'll subtract c squared, and I'm left with this. And then I'll divide by this quantity, negative 2 times b times c, and I have to do that to both sides, and then you get cosine of A. So then you can take the inverse cosine of both sides. If you take the inverse cosine of both sides, you get A right here. So this is the formula that they told us to use there. You can plug in the numbers first and then solve if you want, which is what I do in the web work. It doesn't really matter, but I'll go ahead and plug this in for 22.075 degrees. Now, you are going to have to do this again for a different angle, so because you need one more angle before you can take the other two and subtract from 180 to get a third. So to find another one, you're just going to use a different formula, like for example, b squared equals a squared plus c squared minus 2ac cosine of angle b. So it's the same process from this point. You're just going to use, plug in all the information. This time you're solving for angle b, same exact algebra. You will get a different answer, and then you can take 180 and subtract the other two to get the third. We could do a quick example with a softball field. The distance between home and first base is 60 feet. The distance between the pitching mound and home is 43 feet. So I'm going to plug this into the formula right away. So on the opposite side, h squared equals the other two sides squared. So it'll be 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of the angle, which is 45. And make sure that angle's across from the side you're looking for, which it is. So this is really easy to solve because I can just take the square root of both sides and enter this right into the calculator like it is right here. If you enter that into the calculator, I'll show you that. You can just enter it right in and find 42.43. 42.43 is the distance from the pitching mound to first base. Okay, the last thing is Heron's formula. Heron's formula gives you the area of a triangle in terms of the side length right here. So all you have to do is plug in the side lengths here. First you have to find S though. S is the three side lengths added together divided by 2. And then you plug that into this formula where A, B, and C are the side lengths. So here's an example problem where you can find the area of this triangle. We're going to go ahead and use this formula right here, where S is A plus B plus C all divided. So if you plug this in, you get 84. If you plug in the side lengths, 43, 53, and 72 for A, B, and C. And then you can plug this into the formula right here. So this will be the square root of S, which is 84, times 84 minus 43, which would be 42. And then 84 minus 53, which is 31. And 84 minus 72, which is 12. So you can evaluate that in your calculator and get, actually, I'm sorry, this should have been 41. So if you do that, you get the square root of 1131. I'm sorry, you get 1131.9 about, and that's square meters because we're talking about area. All right, let's try the homework and hopefully this helps.